Hello everyone, my name is Michael and that's the second paper for the assignments. The title of the paper is called Software Architectures and Task Plan Adaptations for Mobile Service Robots, and that is a paper written in 2020s. What is the problem the paper tries to solve? So self-adapt systems increasingly need to reason about and adapt both structures and behavioral system aspects, like in mobile service robots, which must reason about missions that they need to achieve and the architectures of the software executing them. Deciding how to best adapt these systems to runtime changes is challenging because it entails consistent mutual dependencies between the software architectures that the system is running and the outcome of plans for completing tasks, while also consisting multiple trade-offs and uncertainty. Consisting all those aspects in planning for adaptations often yields a large solution space which can be explored at runtime. The papers address this challenge and try to solve it. And why is it still a problem? Because obtaining the best combinations of software architectures, configurations, and task plan specifications is not straightforward and still hard to achieve due to the mutual dependencies between them. The size of the combined solution space for the architecture configurations and task replanning can be easily become too large to be adaptively explored at runtime. So what other did before the author of the paper? The MORPH is also reference architecture suggests separating as much as possible the structural reconfigurations and behavior synthesis problems. This is achieved by including a Go model manages components in its Go management layer that is in charge of the decomposing requirements into achievable reconfigurations and behavior problems, which are assigned to different solver. Then the strategy management layer includes a negotiations process that is assumed to guarantee consistencies among reconfigurations and behavior strategies when they are selected for executions. But the author research showed that because the quantitative guarantees associated with reconfigurations and behavior strategies depends heavily on different pieces of information from multiple models. Example: energy consumptions, software architectures, and physical space safety. These pieces of information are interrelated and change at runtimes, potentially invalidating any of the quantitative guarantee associated with per compiled strategy. These cause solutions able to adapt structures and behavior in a scalable way, as opposed to the per compile reconfigurations and behavioral strategies that might not provide guarantee. And the author contributes approach based on the quantitative and verifications that are separate planning into architectures, reconfigurations, and task planning problems, dividing and the solutions space while still consisting the mutual dependencies. This effectively can adapt task plan specifications and architectures to optimize adaptations decisions. The approach is instantialized using Alloy, which is the lightweight object modeling notations, and also model checkers called Prism, which is the verifications of real-time systems, which are used in a tendon to reason about the outcomes of adaptation solutions. This allows runtime adaptations of the architectures and task plans under uncertainties and in a rich trade-off space. So what is different than the existing solutions? Because this approach really enables optimize runtime decision makings for self-adaptations in what will a perfect and interpretable solution space by dividing the adaptations into subproblems. And the second is to improve the qualities of the adaptation decision to respect the decision making that reasons about the structured adaptation only. Yep. So for the validations, the author used Gatsby simulator. It is an open source 3D robotics simulator, and they evaluate the approach using 2 dimensions. First is runtime's tractability, and is used to see if the planning approach work at runtimes to adapt robots using off-the-shelf robotics softwares and adapt to errors and changes in the environment to complete the missions. Second is the quality improvement, which does the approach generated plans with high utility than the standard self-adapted practice of considering only the structured aspects of the system. And the result only shows that the remarkable improvement over just considering the behavior or structural adaptations and treating them as an independent problem. And there's some limitations to the papers, that is the specified types of robotic scenario and missions. Also is a simulator based evaluation, so it needs to be tested in real world situations.